wonder if you could also describe for us in greater details what the numbers all mean.
The good news about the numbering system in bearings is that when it was established, and the greater news is now, after some people went rogue, most companies around the world use the so-called SKF FAG numbering system, which for most bearings is where the first digit or two, on a 4-digit number, the first digit tells us the engineering style, whether it be a self-aligning bearing, a radial bearing, a angular contact bearing, and so on. The second digit tells us the relative size of the outside diameter. And fortunately, the last 2 digits, which are the most important, tell us the size of the shaft that the bearing is going on. An example would be a 6205 bearing. The 6 tells us it's a radial ball bearing. The 2 that it's a medium-sized outer diameter. But most importantly, the 05, you multiply the last 2 digits by 5, so we know that's a 25 millimeter shaft. The best part is if someone's designing something and they think, oh, this is so special, they can put in a standard bearing right out of the catalog to meet their engineering need because it all fits the same envelope dimensions. You can have bearings running along the same shaft with the same boundary dimensions that have different engineering styles and can accomplish various things, whether it be self-alignment, heavy loads, 2 rows of balls, and so on. Or you can have alternatives with the same shaft with different outside dimensions. And we can show how this works with this little demonstration. Bearings typically come in 2 major categories, ball or roller. And the good news is for different applications, you can have the same boundary dimensions for different bearings to accomplish a different thing. So we'd first like to show, and also once again, the numbering system indicates what the style is. We have some fairly large examples of bearings. This is a cylindrical roller bearing. Inner and outer ring can be mated. A spherical roller bearing with rollers. The advantage here is you have self-alignment. A self-aligning ball bearing. Typically this was in the textile industry, but it's in packaging, plastics, and so on. Then this is a good example of an axial bearing or a thrust bearing with mated parts, and this sits along the shaft and takes load going this way. But one of the key things I want to demonstrate is the options that people have with different style bearings. Okay? These are all the same ID and OD, same inside dimension and outside dimension, but they're all very different bearings internally. So if we put these all together, you'd see they could fit in the same hole, ID and OD, but they're all very, very different. And once again, you'll see the pattern of the numbering system, how it's identical. This is a 1205 bearing, which is a self-aligning, once again, 25 millimeter shaft, bearing that accepts loads radially, but also axially, and it self-aligns to accommodate that. Here we have a 3205 bearing, the 3 indicating it's a double row ball bearing. It has 2 rows of balls, once again 25 millimeter shaft. This is typically used in material handling industry and other heavy duty industries. The 6205, this, once again, 25 by 52 millimeters. These are all 25 by 52 millimeters. 6205 is in the radial bore category, which is the most popular category in the world of bearings. Most motors and so on, compressors, although the bearings are much bigger. Okay. The 87505, this represents the felt seal series. They're no longer using felt seal so much, but these are a great design tool when you need a standoff on the ID. If you put these together, there's actually a small gap. And that's created by an extended inner ring. Okay? The 7205. The 7 indicates that it can take more angular load. Literally, one face has a higher shoulder, so the ball can ride up on it and this can accept more load. Typically, you might want to mount these in pairs so that you have load that can run both directions. Okay? Once again, angular contact simply means more combined load axially and radially. Now, I have these. Now, you might ask, why are there two together? These are machine tool bearings. Machine tool bearings have tighter tolerances. They have to be run in pairs, and they've typically been faced off. And the preload indicates how rigid or tight you want the bearing assembly to be, have to be controlled. Once again, you see the pattern of all the same sizes with different options. The insert bearing here, an insert bearing is what could go into a pillow block or an independent housing. The advantage is larger grease cavity, easier to mount because it can be with set screws or an eccentric lock collar, and you can have a lubrication ring. The most popular of this style for us are free-running bearings, which go into the printing industry, low torque, low drag applications. Now, if you have a lot of axial load and you have it in both directions, think of a car wheel would be the most common one people would relate to. You have a cup and cone bearing or taper roller bearing. This separates and mounts together. This goes in the housing, this along your shaft, put together with a mating unit, and this way it can take load from both directions. High radial load, high axial load. Okay? And they fall apart when you don't hold them together. Okay. Then we have a cylindrical roller bearing here. Once again, with the same envelope dimensions, we can have rollers, and you see, so the rollers are attached to the outer ring. This is an NU style, and you mount the inner ring to the shaft. Many failures, you can see this is why you have potential for failures in this style more than others. When you mate them together, for demonstration purposes, this is pretty simple, but under load it's more difficult. When this is put together, the ring and all the mating surfaces should be concentric and perpendicular. Otherwise you'll have failure because it's easier to score this raceway here. That raceway. Okay? And the last of the styles of bearings that once again are the same would be a spherical roller bearing. High load, not as high as speed, but provides some self-alignment as well. Now for pure thrust, think of a potter's wheel. This is an axial bearing or thrust bearing. Once again, same boundary dimensions, but all the load has to go this way or this way, and it accepts no radial load being referred to as perpendicular to the shaft line. Okay? Now, we've seen that you can have all the same ID and OD bearing, for an application. But also I want to demonstrate that for the same shaft, you can have heavier load carrying capacity by going up that second digit. The second digit, whether it be, let's say going from a 6, in this case a 5, it's a 25 millimeter shaft. You can have a 6005, 6205, or 6305. There's even a 6405. So let's say you've spec'd in that you want the same shaft dimension throughout, but you will have more load at one part of the application, then you just move up on your OD dimension. And they go pretty thin too. There's a 6905 and a 6805. I'd also like to mention that the universality of design in terms of metric dimensions and how they go in ascending order also applies to other products. Some of these other products naturally would be oil seals. This happens to be another style of Isolator Seal. These are 25 millimeters once again. Traditional lip seal in all styles. But also, let's say you have sliding or linear motion that you want to incorporate into your design. Once again, this is a so-called super style or your traditional style. These are linear motion bearings. Once again, can be designed in along the same shaft line. In automation and robotics, these are essential components. spherical bushings, where you don't have rolling elements. Think of a knuckle bushing on a style of excavator would be that. And then this shows pretty easily, once again, thrust bearings. So once again, conforming to the same dimensional categories and boundary dimensions that we had discussed earlier on the radial ball and cylindrical roller bearings.
Hi, Steve. Let's talk a little terminology if we can. I'll throw out some terms typically bandied about, and the first one is ABEC class.
ABEC class refers to a standard of tolerances that were established once again in the 20s. Bearing manufacturers got together and said, not only are we going to have a numbering system that's uniform, but we're going to have a set of tolerances. So they're literally saying standard grade, which is referred to as ABEC 1, will have the following tolerances. So they know that the inner and outer ring and the balls conform to a tolerance that goes out to 3 or 4 decimal places. An ABEC 3 bearing has tighter tolerances still. Now, when bearings were actually 40, 50 years ago, a standard bearing was an ABEC 1. Now with metallurgy improving and manufacturing techniques, most bearings manufactured worldwide are close to an ABEC 3 bearing. They run quiet and smooth. If someone needs more precision, they want less what's called run out, where the bearings could wobble a bit, and speed, they go to an ABEC 5 or a machine tool grade, which is ABEC 7 or ABEC 9. So these are critical values. One of the important things we stress as a company in terms of sourcing is that people only buy the accuracy they really need. Some people say, well, I only want an ABEC 1 bearing, pay for it because it's less expensive, for an ABEC 7 application. That will lead to failure or poor performance. It also goes the other way. If someone only requires an ABEC 1 or 3 grade bearing, they should not be buying an ABEC 7. The one little anecdotal thing that happens here at our pickup counter, we often have people who are on rollerblades. They'll walk in and say, okay, I want a 608 bearing, which is an 8mm bearing, bore bearing, which is the second most popular bearing in the world. It also goes into every vacuum cleaner motor and mag motor. And they'll walk in off the counter. We have a big student population in this area. They'll say, I want that 608 bearing and I want an ABEC 7. And we look at them and say, you don't need a 7. Oh, but that's what the local skate wheel shop is selling. Well, the fact is an ABEC 7 bearing can turn, let's say, has a limiting speed of, let's say, 80,000 RPM, something crazy like that. Whereas a standard ABEC 3 bearing, which might cost $2 as opposed to the ABEC 7 at $8, will have a 20,000 RPM limit. Also, the bigger factor is once someone steps off a curb on a rollerblade on an ABEC 7 bearing and they clunk, they hit that raceway, they've put a minor, imperceptible to the naked eye bump or a little divot in the raceway, and it brings the limiting speed down to 20 or 30,000 RPM anyway. So once again, they'd be paying too much for an application that doesn't require that style or expensive bearing.
Well, you just saved our inline skaters in the audience a bunch of money, and I'm sure they're thankful for that. Next, can you tell us about internal clearance?
Internal clearance is one of the more misunderstood aspects of bearings. It refers to the amount of displacement a shaft would have in relation to the outer ring. For a bearing to turn, for the ball or roller to turn, you have to have some gap between the balls and rollers and the rings. This is a very tight tolerance. For most applications, for motors and pumps, we call out what's called a C3 clearance. People hear this term internal clearance and they see the letter C and a number after it and they wonder, well, what's that really mean? What it means is that in ascending order, C 0, 2, 3, 4, and 5 and so on. 5 is unusual. That means there's more clearance between the balls or rollers and the running surfaces. This is really essential to have because what it allows is for a film of lubricant to run through the bearing. It allows heat to be dispersed. If the tolerances aren't proper when you mount the bearing, you're going to get the rings tighten up and take out the clearance. So it's really critical to have the proper life. Also, certain applications run hot. We do a lot of business with a railroad drive, a traction motor bearing, where it's a C4 clearance by design. Under initial load, when it's turning, it sounds a little clunky. You can actually hear the rollers. But what happens as the bearing heats up, thermal expansion of the metal actually makes it a C2 or C3 clearance, tightens it all up, and it runs smoothly and perfectly. So it's very important to pay a lot of attention to clearance. Too tight a clearance, the bearing will seize. Too loose a clearance, it'll sound like rocks are in the motor.
All right, up next, angular contact.
Yes, angular contact is that combined load. Some bearings are actually designed in to take angular load as a standard, as opposed to just an infrequent load. Bearings like this would be the 7200 series, which are extremely popular in machine tools and in pumps, where some of the load can be from the side. And it's very important that it be accepted properly. Typically, angular load, especially in angular contact bearings, the 7200 or 7300 series, which are very popular in compressors, are used in pairs so that the load can be from either side.
Okay, how about bearing life?
Bearing life refers to the number of revolutions a bearing can accomplish under normal fatigue, under normal compressive stress. Most bearings can go a certain amount of revolutions, and there's a B10 life where a group of bearings are tested. 90% of a group of bearings can go a certain number of hours.
Well, Steve, what would be the optimum seal for challenging environments? Is that the Isolator Seal?
The Isolator Seal, this solves a problem because 90% of bearing failures are due to contamination. The Isolator Seal works by an internal labyrinth. These are easy to mount, they're standard size dimensions, and they solve a lot of problems. Granted, more expensive than a typical lip seal, but once again, to avoid a failure, this is a solution, particularly in pumps and compressors.
Well, Steve, one of our attendees needs to create a shield on an open bearing, and he questions whether the Nylos ring would work for this application.
Most people don't realize by utilizing this ring, which fits flush against the outer bearing surface, we can actually create a seal or a shield on an open bearing. This is in extreme situations where you don't want the bearing to be contaminated. You want to keep grease in, contaminants out. So this has been a real solution for a lot of people.
Now, what can you tell us about split bearings?
Split bearings are a very unique solution, and for the right application, they make a world of difference. This is the FAG style split bearing, and basically, I'm not going to take it apart because all the balls or all the rollers would fall on top of me, but basically, everything has been cut in half. So when it's time to replace it, the bearing is sitting in the housing. Simply take off the top part of the worn bearing, you wind in the new one, and you're back in operation in hours as opposed to days. This style uses spherical rollers. The Craft style, or the former, what people refer to as a Cooper style, utilizes cylindrical rollers. Okay? This is typical in propulsion, marine drive shafts, and so on. So once again, take off the top cap. You can wind in, these are all split. It's all split off. And you can drop in a new one, simply wind it around. But this is a very unique solution that saves a tremendous amount of downtime, especially in larger applications. This way you don't have to take apart your shaft, take off your gears, and really look for other problems. So this is a great solution.